Welcome to the PanCap video, Database Consolidation with TiDB. My name's Jeff and I'll be your guide for this journey. So during this video we will discuss the purpose of database consolidation, resource isolation and control in TiDB, storage tiering and differentiated high availability in TiDB, and last but not least we'll cover some customer use cases. So let's begin with why. You're probably asking yourself, what is the purpose of database consolidation? Or in other words, why would anyone desire to consolidate databases? In the world of databases, data consolidation refers to the process of combining multiple sets of data from different sources or databases into a single location. This can be achieved through various means such as data warehousing, data integration, or data federation. So data consolidation requires new data models and ETL code. On the other hand, database consolidation refers to the process of combining multiple databases into a single database or cluster. The databases are moved as is to the new environment. So for example, you go from 10 separate database instances to a single database instance. There's no need for data model changes or ETL. Database consolidation is typically done to simplify database management, reduce cost, and improve scalability. While the terms data consolidation and database consolidation are related and may involve similar technologies and techniques, they're not interchangeable. Data consolidation focuses on bringing together different sources of data, while database consolidation focuses on reducing the number of databases in use. In summary, data consolidation is about consolidating data from different sources, while database consolidation is about consolidating multiple databases into one. So why do we need to do data consolidation? One is to prevent over-provisioning. So in a traditional one application per database environment, we always adopt the method of purchasing excess hardware resources to cope with future business growth and load fluctuations in order to secure system performance and reliability. For example, a critical system may initially only require 100,000 queries per second processing capacity and 100 terabytes of storage space. But in our architectural design, we often need to reserve more than twice the required computing power and storage space. Next, we have development and operations inefficiency. This one's pretty simple. There are two aspects here. One, it takes more DBAs to manage 300 databases than it does to manage one. I pulled the number 300 out of thin air. There's nothing magical about it. I'm just using it as an example. Two, 300 database installs requires more resources to one than one single database install or one single database instance. Finally, we have limited capacity to scale. So scaling a single database cluster is much easier than tracking and scaling 300 of them. Once again, 300 is a made-up number. So here's some reasons why you may need to scale your environment. So the first one are sudden surges in traffic, load, and data due to unexpected events. These types of events often result in an urgent need to scale. The key word is urgent. This is much easier to anticipate in a consolidated database environment. Next, we have excessive accumulation of historical data seriously affecting online operations. So this is the inability to separate cold and hot data. Next, we have failure to meet the needs of both transactional and analytical workloads. That's a big one. And finally, difficulty in controlling costs due to the inability to recover and reuse resources after business units enter a decline phase. This is much more difficult to do when you have multiple, in our case, 300 databases than when you have one. I'll let you in on a little secret. Not all databases do a great job at database consolidation. Shocking, I know. But before we start, I need to warn you about something. I'm going to use the term multi-tenant. Unfortunately, this term means about 1,000 different things in the database and cloud worlds. We're going to keep it simple. When you hear multi-tenant, think about it in terms of database consolidation. Our definition of multi-tenant will be a multi-tenant database is one upon which we can implement database consolidation. That is, a single database cluster that will effectively manage multiple corporate databases. You can think applications here. So let's say you agree with me and you decide you need to consolidate your databases. What capabilities should you look for in your new database? Well, the first is isolation. Each database may have different performance characteristics, data volumes, and availability requirements. Our new database must be able to manage these divergent requirements. This is not a problem for your single tenant databases because, well, they only run a single application. You can customize the instance to your heart's content. On the other hand, your new multi-tenant database must have the ability to customize the setup on a per application basis. Another way to say this is a per database basis. For example, some applications have a higher priority and often require more computing and storage resources, while other applications are idle for long periods of time. So likewise, some systems experience sudden increases in workload after certain periods of use, while other applications enter a period of decline, going from being very busy to having a low workload. Our new database must be capable of resource control, which means it can allocate CPU processing power and I/O accessing capabilities to applications based on their needs, thus dynamically adjusting the allocation of computing and storage resources among the various applications. We also need the capability to separate historical and current data, as well as different demands for data replication. This is high availability. From various applications, we will explain these features in detail later. Next up is scalability. In order to avoid over-provisioning costs, our database must support easy horizontal scaling. This means that when migrating from a single tenant to a multi-tenant database, we do not have to reserve processing power and storage space. Instead, we can wait until the data volume and load reaches a predetermined point and easily expand our computing and storage capabilities. Likewise, when the load decreases, we can easily reclaim our computing and storage resources without affecting the user experience or the application. Next, we have translytical capability. Okay, Forrester Research made up a word. I think we need to describe it. So translytical describes a new generation of data platforms that combine transactional and analytical processing capabilities within a single system. Traditional single and multi-tenant databases often cannot handle both transactional and analytical business use cases at the same time. They require time-consuming ETL conversions to be implemented in two different database systems. For example, you run your transactional workload in DB2 and your analytics workload in Teradata. So this approach requires multiple systems, DB2, Teradata, could be others as well, and an ETL process to move the data from the transactional system to the analytics system. This is a lot of work and usually winds up being a maintenance nightmare. Next up is easy to operate. This one should be reasonably self-explanatory, but let's take a look at it because it's important. Due to the large number of single-tenant systems migrating to multi-tenant databases, continuous performance and high availability monitoring have become an essential feature. And by essential, we mean required. You have to have this. A convenient and quick resource scheduling interface can help us simplify operations and improve response times, thus reducing operation and maintenance costs and improving efficiency. In other words, easy to operate. And finally, lower cost and high efficiency. Being able to dynamically allocate compute power and storage resources according to the workload demands of an application, separating the scheduling of computing and storage resources, this all allows us to achieve more precise cost control after data consolidation.
If you want to learn more, scan this barcode and then you can get access to more PinCap training and certification resources.